Have you ever just done an amazing solve? Like you got your personal best, and you feel like, wow, I'm on a roll. You're all pumped, ready to not just get the PB single, but the PBA05, PBA012, PBA025, blah blah blah. You sit down after that celebration, only to get a terrible solve. Well, by probability, this should happen to everyone. Why? Let me explain. With Sir Francis Galton's notion of regression to the mean. The rule goes that, in any series with complex phenomena that are dependent on many variables, where chance is involved, extreme outcomes tend to be followed by more moderate ones. So what does this mean? Well, it means that for a series of events, there will be high points and there will be low points. For example, you may average 10 seconds for the 3x3 cube, but sometimes you'll get a 7-second solve, and sometimes you'll get a 13-second solve. However, after 1,000 solves, your session mean timing will always regress to your average timing, which is your average performance, which in this case will be 10 seconds. If I take a random number generator that generates numbers from 1 to 10, the first number generated may be 9, and the second may be 3. It's all random. But eventually, the mean of all the generated numbers will be 5.5. The more numbers I generate with this random number generator, the more the pattern will show. The mean of all the numbers randomly generated will regress towards the mean, which in this case is 5.5, as that is the mean of the numbers from 1 to 10. So to put this back into the example of cubing, you will have your average performance. So let's say there's one day where you do a session of 100 solves. Yes, you will be improving slowly, but this improvement is negligible in this scenario. Hence, when you look at the trend of your solves, you will see dips and you will see highs. This is due to your timings being decided through several factors, some not in your control. It can be dependent on your focus level, what PIR you get, what ORR you get, how easy the F2L is, the simplicity of the cross solution, and much more. All of these are random and can decide how fast or slow a solve is. Hence, when you get an unusually amazing solve, the timing is far from your session mean. Therefore, statistically, it is very likely that you will get a terrible solve right afterwards, to regress back to the mean. This will also apply if you get a terrible solve. When you get an unusually horrible solve, that timing is far from your session mean. Therefore, statistically, it is very likely that you will get a great solve right afterwards, to regress back to the mean. So this is how you explain your inconsistencies with the power of math. Come to think of it, the worse solve you get, statistically, the better your next solve is going to be. So this is how regression to the mean affects your cubing timings. And I hope that this was kind of informational, and I wish you happy cubing. Hey, thanks for watching this video. I really like math, and thus I'm doing something new, and I hope you guys enjoy this kind of video. Through this video, it kind of makes me realize how good at cubing you must be to get a great average of 5. You cannot just rely on your luck, but actually have to be that fast to get that fast of an average of 5 in a competition. So do tell me in the comments if this was a good or terrible video. If you enjoyed, I will appreciate it if you subscribe and like this video. See you soon.